you, Dr. Shrishti, for warm welcome. So first of all, what I'll do is I'll just kind of brief about what SPSS is and how you are, how you can use it for your data analysis and kind of have a warm up with SPSS before we actually start doing the data. So first of all, with SPSS, today what we would be doing is first an introduction, how we open SPSS, we close it, we kind of understand the structure of SPSS. Then there are data entry windows, how do we enter the data, and what are the necessary basic steps to understand your data, through SPSS. So now SPSS is no longer a statistical package for the social sciences. It is statistical product and service solutions. So Dr. Shrishti has already told you about the brief, of SPSS, and now it's IBM owned. And the latest version that we would use today is the SPSS version 22. So if we look at SPSS, we can do data collection. We can actually also have packages that can look in for data collection. Then we have for data mining also, and we can also use it for big data. Okay, the basic package that 17 version is there. It is available for the students, but there is a trial version that is available, and you can probably update it through your institution or maybe personally as well. So SPSS is one of the most common software that is used for statistical analysis and the most basic one. The other ones, as in R and Stata, they are little higher and they're slightly command. Just say for example, Stata is command based. So it is slightly difficult to remember all the commands and then proceed for it. So SPSS is the most simplest and basic software for your data analysis. Now, before we move on to this, so now what we expect from SPSS is first, it shows our data, the entire data that we have. It tells us what kind of data format it is. Let us say if we have names in our list, so it would give us a specific range as what type of data is named. Whereas if somebody's age is also given, so that is something which is numerical. So we will also have a data variable view where we can see all the variables that we have in our data sheet, and then we can see what kind of data it is. Let us say that numerical data has decimals in it, so it will give us a brief about how many decimals are there and so on and so forth. So SPSS, the basic format is .sav file, and it also supports XLS files, Excel files, CSV and .dat files. So for all of the beginners, I would always suggest to enter your data in an Excel sheet and then import it in SPSS, because it is always easier for everyone to kind of go back to a specific cell or a specific row or column in Excel sheet and then edit it if there are any corrections afterwards and then reopen in SPSS. But once you do in SPSS, then again you'll have to save the entire file and the entire exercise gets repeated. Okay, so I would always suggest that you kind of enter your data in an Excel sheet, save it in an XLSX file, okay, or Excel 97 to 2000 version for those who would not be able to understand .xlx. So use it in a format Excel 97 to 2003 format. So that is the simplest version to import it to SPSS. Okay. Now, why most of the people have not been using SPSS? Because it is not freely available and data mining is not really adapted to SPSS. So you kind of have to mine the data, import it in SPSS, and it takes a little bit of your space in the system. So that is why people kind of use it less. But it is the most commonly used software for data analysis. Now, the two things that I would suggest you to use SPSS for is first is management of your data and then is your data analysis. The simplest and the most beautiful diagrams, the figures that you would get is in SPSS than in Excel. It looks very scientific, very methodological, and the outputs are pretty clear. Okay, so you have to looking for a specific value and then your interpretations are done. Now, within the data management, you can define your variables there, code them, recode them, edit your data and all that thing. But again, I would say always use Excel for entering your data, code them there and edit wherever necessary in your Excel sheet, save it and again open it here. That's the best way to save your data, to make any changes in your data at any point of time. Okay. Now, when you would want to open SPSS, this is how you do it. If you have installed it, that is fine. Otherwise, if you have taken it from somewhere, what you do is you paste the entire SPSS folder in your system and open the file where the application manager is there. So that would help you install SPSS in your system. So now if you look at the window, there are two sorts of views here, data view and the variable view. Okay. So in data view, those who want to enter the data directly here can enter it here. Okay. So I can put in here. First, you have to go to variable view, put in the entire, let us say, name, then what type of, whether it is numeric, whether it is comma, dot, scientific, date, dollar, or whatever. So now all the variables that have name or any alphabet in it, alphabetical, they go into the string value. Okay, so you put in a string. So that is a string domain. So width is something which is, you can define. So if the width is 8, you can put in only 8 alphabets in order. And if you want to increase, you can increase it from here. Okay, like this. Now decimals would definitely be not there in the name. Then label is something which you can do. Now, if I want to kind of rename it, the now name of the individual or the participant, and I want to label it as participant. So now my entry name would be read by SPSS as participant. Okay, so that is something that we can do here. Now values. Values is something that we do not do here, but supposingly if we have age or smoking, so we can always label the values. Okay, so if the value is 1 and I want to label it as value is, let us say, age is 50, value is 50 and I want to label it as old age, I can do it here. And then likewise, all the individuals who have age 50 would be now read as old age. Okay, so that is something that you can do in SPSS here, right? Now, if you look at the columns are there, so there would be 8 columns in it. Now, if you look at this align, so this is about alignment of the cells, nothing else. But if you look at measure, this is something which is important. Now, there are 3 things that you would be able to see here. When we would open the data sheet, you would be able to see 3 things there. One is nominal, one is ordinal, the other is scale. Okay. So what happens is, when we have, see, these 3 things are visible. So scale, ordinal and nominal. So you have to first understand what does it mean. So scale is something which is scalar, which is measurable on a scale. Let us say height of an individual or weight of an individual or any parameter that is scalar in quantity. Okay, so that is where we choose scale. So since my age that I know, age is numeric, and I want to read as, and I want SPSS to read it as a scalar quantity which can be measured or put on a scale, I'll choose scale here. Okay. Now ordinal. What is ordinal is when we have responses in grades. Let us say we have a class of 50 students and first position, second position, third position, fourth and fifth, likewise. So I would want SPSS to read that data, that data set in an ordinal value. So means ranks. So ordinal is something as ranks. So we use ordinal or we choose ordinal measure in that case. Now nominal. Nominal is something which is supposed to be attached with the string variable. So if it is numeric or alphanumeric, it would automatically take it as nominal. But along with it, when the SPSS, kinds of read the entire data sheet itself, there would be certain sections or data sets that you would get. Let us say somebody's income. So, and you've given in your questionnaire as an option as greater than 1 lakh per month. So this greater than symbol would be read by SPSS as nominal. Okay, and in that case, we kind of, since it is numeric, we go back to the variable view and we change it here. Okay. And then nothing much about the input, because this we are putting up as input. Okay, so for a beginner, these many informations are important to understand as to what data is, what a variable view in SPSS would be like. Now, if I look at data view, it would give me the entire data sheet, or if I want to enter here, see, you can see name here. Now you can enter any name here in the data set. Now, if I want to address age, so if I address 50, so 2 decimals, because in the variable, the decimals have been selected. So if I want to reduce the decimals, I go back and change my variable view and make it 0. See, now no longer the age has 2 decimal places. Okay, so I can just put in anything here. Okay, and that way I can put all my variables here and then look at the data view and kind of start entering the data set here. I hope this much is clear to everyone. All right. So if you have any questions, you can just stop me there and ask any questions in between if you have. All right. So what Dr. Suchita asked me to share today was, about understanding of the data and how we look at the data actually. So I'll be doing that right away. So now this is the basic thing. Now, how do you open an Excel sheet in your data? Now that you have responses from your participants, or for any survey, if you have responses, you get a Google sheet, right? Well, most of you, if you would have been ever, using this Google form. So there's an Excel sheet that you get. Okay, so you can download the Excel sheet. You get an Excel sheet, and you kind of clean your data. Cleaning the data is very important, because once you get the data, it's very raw. Okay, and if you have those open-ended questions, there are categories of it that you would want to clean. Let us say there are open-ended questions that why do you want to use SPSS? So people would have given certain types of answers. First thing. Second thing is if you have given multiple choice questions. So people would have given it on multiple choice or chosen a specific multiple choice answer. There are 2 ways to analyze your data. First is you either code your data, give them rankings, and then analyze your data. The second is you use directly those multiple choice answers and analyze the data. Okay, but there would be certain tests that would be covering in the next session. So that was something which is about let us say linear regression. So you want to understand of the 10 factors that you had collected answers on, which is the most influencing factor. So in that case, you will have to definitely code your data sheet. So cleaning of data is very important when it comes to any data set, whether you use any software, whether you use SPSS, data or R, cleaning of data is most important. So first thing is you have a look at your Excel sheet. So I now share the Excel sheet that I had shared. Okay. So now I hope this Excel sheet is visible to everyone. Now, so this is a data of 50 individuals wherein we have lot many data that are available here. So I kind of first of all understand what my data sheet is. All of you should initially look at your data and kind of understand whether I can code that data or not, or rank them or not, or whether it would go just like that. Okay. So understanding and feeling the Excel sheet and data is most important. So now herein I have subject number, the serial number, an individual's name, then I have age. So this is something that I got. What I did was I coded the age as per my convenience. Okay, so if you look at an Excel sheet, the age range is somewhere from 34 to 86. But I do, there are two things. I want to look at this specific age for each age, or I actually want to categorize my age into different setups. Let us say below 40, 40 to 50, 51 to 60, and 61 to 80, or maybe 70 and then 70. So I can code my data according to that. All of you know coding of data in Excel. So I hope you can filter out and code the data. The next is gender or the sex of the individual. So male and female, I have chosen M and F here. What I did was I coded my data. So this is the simplest thing that you can do. You kind of do everything in Excel, code it right away in an Excel and import it in SPSS. That's the simplest thing that you can do. So then you don't need to go to your variable view, change every label or change kind of code everything there. You can do it in your Excel, save it and use it. Okay. So I have kind of coded most of them. Now, if you do a survey, you get for smoking status, let us say smoking. So you kind of get a response in yes, no, or ex-smoker. Okay. So this is something that I had an old data sheet and I kind of simplified it for everybody's use. So the same thing I got here. So I would suggest all of you to kind of, there are responses that you think are normal responses, and there are responses that you think are not normal, or they're, increasing in severity or grading. Okay. So I would always suggest you people to kind of code your data in a form in the entire sheet in a consistent manner, wherein you keep normal thing, normal response, or a normal phenomenon as 0. And the abnormal ones to be 1, 2, 3, or severity with respect to severity is 1, 2, 3. Although it doesn't matter, but it eases your understanding. That's it. Okay. Now I coded my smoking status. For this data sheet that you all have, 0 is something which is non-smoker, and smoking yes is something which is 1. Now the next one is again about alcohol. So what you can do is also keep it here for everybody's ease, but for your own ease, you can put it here as no or yes as 1, no as 0. Now again for diet also I've coded it here. Now why I shared such a huge data sheet is for the reason when we do the same data set analysis in the next session, you would be able to understand why we are putting up 50 variables or 10 variables. So these are my variables and these are my data responses. Okay. Now if you go back again, I've coded most of the data sets in my sheet. Clear? Now, shall we import the file to SPSS? All right. All right. So, I go to File. Now, before that, you have to close your Excel sheet. Remember this, that you have to close your Excel sheet and then open it in SPSS. Otherwise, it would not import the file. So, I go to File, I go to Open, I go to Data, and then you would get the path wherever your file is saved. Okay, so I choose my desktop. Now, so here the Excel sheet is not visible if you would see. Okay, so I go to this files of type and change it to Excel. So now all the data sheets that are there in the Excel format would be visible. So this is my sheet that I have to select and I'll open it. So now now in an Excel sheet, if you have 3-4 Excel sheets, so 3-4 sheets, you can choose from here. Okay, so I'm choosing this and opening it up. So now my data view is visible. Yeah. And this is my variable view. Now, See, the subject number, it was a numeric thing. It was scalar in quantity. So the measure here itself is taken as scale. Now, if you look at the name of the individual, it is something as alphabetical. So it would take it as nominal. Okay. Now, all of this. Now, supposingly, I want to change the label here. I want to put it as serial number. I can change the label here. Subject name, I only want it as name. I can put it name here. Now, if I want to put age here, I put age code. So probably you can create chart from here, graphs, go to legacy dialogs. And because this chart builder will have something defined variable properties, and then you will have to kind of create your values here that are supposed to be placed, and then it would create a chart. So it's better that you go to graph, click on legacy dialogs, and then you create any type of chart that you want. Let us say I want to create a bar graph. I click on bar graph. I want to create a simple bar graph. How many males, how many females? Okay. So I click on define. So I'll get this type of tab. And I want to see males and females and scopus. Okay. So how many males and females? And I just want to see percentage of cases. And or maybe the numbers. If I want to see numbers, I will click on numbers. If I want to see in percentage of cases, percentage. So titles, whether I want to give any title or not. So let us say sex distribution. I can click on this. Done. Options, I don't need to do anything. Now, supposingly there is a variable where I forgot to write male or female, or I forgot to categorize. Okay. So I would click on this display group defined by missing values. So there would be another group except for male, female. There would be another bar in the graph where it would mention where it would give frequency of those missing values. Okay. Now I click on OK. See, this is something that I got. So the entire data, these many are males and these many are females. Okay, so sex distribution is here. Now, if I want to change this, so cumulative numbers or number of cases. Okay, so this now is based on the number. This is based on percentage. Okay, so now percentage of females and percentage of males. Okay, now this is something that I cannot present in my presentation, somewhere in my class. So what I'll do is I'll kind of edit this chart. Okay, so you can edit a chart in the SPSS output only. You double click it and it would show something like this. Okay, so I don't want this, or if I want to relabel it as sex, so this is fine. So now I click on this, but I want to increase the font or decrease the font. I can do it from here. Okay, so text style. Okay, so I want to choose maybe, let us say I want to choose it as bold, but I want to change my font. So I can choose the font according to my own comfort. Okay, so you choose your font according to your interest. So you can, let us say I want to go for Arial black. And I want to choose the color. I can choose color here also and apply. See, now this is changed. So you double click it, then you click on this unless a box appears or your cursor appears. So you will be done. Now I don't want these 0 and 1. So one option is you go back to your labels in your variable view and change it there. But since I coded this data, I don't want to do this. So I can do it in my chart editor. I can click here and then write tables. Then I click on this. Fine. So this is it. But I want to make them, make it as bold. So I go to this thing. So now when you single click it, both of these domains on the right side, this right axis would be, this y axis would be selected, x axis, and you can just go to this thing, size, normal, bold or italic, whatever I want, and click on apply and then it will be done. Okay. Now, if I want to change the color of this chart, I again go to this thing, fill and border, and let us say I want some other color for this. So I choose as gray and I click on apply. Okay. Now, apart from this, let us say I wanted the caps to be round. I click on round, or this is the border style, and accordingly, whatever I want to choose, I can choose it accordingly. Okay. Now the bar options. If you look here, there are bar options here. Now, the bar options is something that would reduce or increase the distance between these two bars. Okay, let us say I want to keep it as 50%. I click on that and that is it. I click on apply and then close and it would be done. Now I want to change, let us say the border of it, I can change it here, whatever I want to choose, I choose borders and probably I want to choose the border this color, that is it. And then close. Okay. Now, here I want to change this. Okay, again I click on the scale, go to scale, and I want the maximum to be, let us say 100. And the minimum increment that it wants is, let us say 5 or 10. Okay, that would depend on my way of representing my bar graph or chart. Okay, in Excel also you do the same thing. In SPSS you have to do the same. That's all. And then if I want to choose bold, I go to bold and apply and close. That is it. Now it would not be saved until here. Okay, then you have to go to close and then see. Now it is closed, changed. Again, if I want to edit it, I go to this and I don't want this. I go here and I kind of delete it. That's all. And then again I close it. Now see, this is it. Okay. So this is how I do this. Now, there are two options of exporting your data set. What you do is you copy paste it, you copy it, and then you paste in your Word file or PPT or whatever it is. Okay. Let us say I want to paste it in my PPT. And I paste it. So, okay. So this is it. Or the other thing is you export your data set. So you right click on this figure, go to export, and then whether you want to export all means the entire analysis that you've done until now, it would export, or all that is visible, only these two graphs, or whatever is selected. So I want only the selected one. And I click on Word file or text file or whatever. So I want it to go to a Word document. I click on Word RTF. Then this is the path where I would want to save it as. So let us say I want to save it on the desktop. And probably let us say I want to save it in this particular folder with the file name. Text-wise distribution. And I click on OK. I click on save there and then click OK. So if I go to this particular folder now, wherever I will save, now I got this file. This is it. I can copy it from here and paste it wherever I wish. So this is how you export the data set. Okay. So again, I'll show you how you save your data set. You select anything. If you want to save the entire data set, you go to file and also save it as save as. And wherever you wish to save as SPSS or SPV version, it's better you save in SPV, which is the default format. You choose your path wherever you wish to, and then it is saved. Now, in this particular format, what would happen is your entire file of this output would be saved, but not in Word format as we just saved. To save it in specifically in Word format, what you do is right click, export. Whether you want to save the entire data sheet in a Word format, then you choose your path. Okay, and I want to save it as complete analysis. And I click on save and then I click on OK. Now, if I go to this particular folder where I saved my data set and I open this complete analysis, this entire analysis is now exported. Okay, and I can go to whatever analysis I want to see and then copy paste or edit whatever way I wish to edit. I hope this much is clear. All right. So we probably now move on to the next section of it. Any questions that you have, you can just ask me now, or you can ask whenever you feel like. All right. So the next part of it is the other type of chart. Okay. Now I want to see the type of tables that I had created. I want to see them in the chart or the bar graph. Go to graphs, legacy dialogs, then bar graph. Then I want to see them cluster wise. Let us say I want to see them cluster stacked. Stacked as in within one column, I want to see the number of variables. Okay. You always click on the summary for groups of cases. It is better that you click this so that your entire data is summarized in a particular table over the graph. Define. Now again, I would want to see on the category axis, I want to see as excluded. Now I want to define my stacks. Define my stacks by, let us say, smoking status. And that is it. Percentage of cases or number of cases depends on my area of interest or my way of presenting my data. If you want to change the title, now my title is now stacked by cases. So smoking status to text file distribution. And click on OK. Now, if you look at this, so this is how you get your data and the region number. This is what it is. Now, within the males, okay, within the males, none of them was non-smoker, and within females, you have these many smokers and non. Now, with colors, I'm not able to understand what it is. I go back to my editor. I kind of edit this, select this. Single click would edit it and double click would open this tab. Now I want to see them as non-smokers. Smoke. Now, if I don't want this smoking to come here, I can remove this. Now, if I want to change this, I go here Okay. And I'm good to go. If I want to change the scale, I can change it from 5. And maximum if I wanted to 150 is fine because it has clubbed both of it. So this is okay. So it will show it this way. And when I close this is stacked. Okay. So this is a stacked bar graph, and this is a simple bar graph. Then supposing if I have to cluster bar graph, if you would look at most of the tables that goes for business presentations, you would see a lot of graphs that are stacked besides each other. So you go to graphs, you click on legacy dialogs, bar graph, then I want clustered. That's fine. Category access, let us say I want it again sex. And then define clusters by smoking status. Again, same. Percentage of cases. I don't want to maybe fix up a title here and then click on OK. So this is how you get it. Okay. See here percentage of cases. So this is percentage of cases. Now it has calculated it separately. So this blue, this is your non-smokers. Now this blue is missing here. Non-smokers are not there in the males, and within females percentage of cases is 100% because this is it. Now this green is smokers, so this percentage is somewhere 57% or 60%, and this percent is 100%. So if you plus both the greens, it would be 100%. If there would have been another blue, both of the blues would have been 100%. Is that okay for everyone? Alright, so if I want to edit, I can edit it accordingly as we had edited earlier. Now, let me just show you how it looks if I choose another variable. Okay, so now see, this is how another variable I've chosen. It appears pretty good. So now if I sum up this blue variables, it would come out to 100%, and both the greens would come out to 100%. So now what does this graph show is, now when I look at this, when you would always, because when you would already know the data, you would know this is normal. This is so the waist hip ratio, the sex-wise distribution of waist hip ratio is now done. So the blue are the normals. So amongst the females, these many percentage is there, which is normal, and amongst the males, these many are normal. And amongst females, these many are having high WHR, and these many are having, amongst the males, these many are having high WHR. Okay. So you can always choose the presentation of the data that you would want to see. Now I want to see, maybe percentage cumulative. I can choose another statistics and it would show me this cumulative percentage. Okay. So this is how it would show. I hope this much is clear to everyone.
Yes, ma'am. It's clear.
Okay. Now, if I want to go to another type of representation and I want to see the box plots, the box plots. So what we do is, now I specifically am comfortable in looking at the box plots when I want to see whether my data is normally distributed or not. So I hope you know normal distribution, what normal distribution is in a data set. Okay, so for everyone's clarity, normal distribution is something that we see across the data. Now, if you imagine the height of individuals across the world, okay, there would be less number of people who are very short. Okay, so we start with height as like this on an x-axis. So if I start plotting height in centimeters or feet, So what I would see is very less number of individuals would be very short, and then it would gradually, the height would gradually increase, and then again it would reach maximum, and then again it would start reducing, right? So we get a bell-shaped curve. Okay, so that is where your data is normally distributed, and in the middle of it, then when you intersect it, it divides into almost two equal halves. Okay, so in your entire data set, half of the individuals would fall on the left side and it would gradually decrease, whereas if on the right side, half of the individuals would be, increasing and the taller individuals would be going down. Okay, so if you imagine the height of individuals across the world, very less individuals on the left side were very short and very less individuals on the right side very tall. And somewhere it would peak in between, and if you see, it would imagine it as a bell-shaped curve. So that is your normally distributed data. Okay, so we would do this when we do maybe in the next session. We will do. I will just tell you how you look at your normal distribution of the data. By just 1 or 2 clicks, you get that thing, and you interpret whether my data is normally distributed or not. Because that is important for your further analysis. For mean, median, fine, you can present everything. But for linear regression, or let us say I want to compare means or medians, I would want to look at my distribution of the data. Okay, so I pretty look at this box plots and I get to know whether my data is normally distributed or not. Okay, or even at looking at the means and standard deviations, how diverse my data is. So I click on simple. I just want to look at the simple bar graph. So now here I look at age is something which is being read as nominal or string right now. I go to my data view. I look, see, this is nominal. I change it to scale. Here it is nominal. That is okay. Now, so this is something that I want to look at. Variable age and category axis. Maybe I just want to see them sex-wise. And I click on OK. So this is it. Okay. So now that there is this particular line shows the mean age of males. So this is the mean age of females, which I mean you can see this box. Okay, so this would generally kind of suggest you the mean of the age entire group, and for this particular group, and this would generally be the interquartile age. So this box would represent your 25 to 75th percentile. Okay, and same here. And these boxes, these arrows outside the box represent your outliers. Then, sorry, these are your outliers. This individual number 31 has an age which is outlying, and this is the entire range here. Okay, so this is how you can actually present your data in box plots. So I can just change and bring them together also. So I kind of go to this and click on this bar options. I can change it here. Change the bars here. Change the chart size here. Variables here. These are the variables, and change my style accordingly. Now, I don't want my data set to represent this 3031. So what I do is go here, click on this, double click on this, and just delete it. That's all. So amongst the females, there is one outlier. So this is how we see outlier. Okay. And in this, see, this is more or less symmetrical, if you would see. But in these, my mean is coming out somewhere, on the lower side, which means this is not something which is normally distributed. So amongst females, majority of them are on the lower side of the height, and lesser number towards the upper side. Whereas if you look at this, more or less equal number of individuals are distributed on the upper side or the lower side. So which means the data set is little bit normally distributed amongst the males. And that is how you kind of interpret using the box plots. Thank you, Dr. Man. Thank you, Dr. Suchita, and thank you, Dr. Shrishti. And thanks to all the participants.
Good afternoon, everyone, and welcome to the day 6 of the 7th day FDP on evolving research paradigms in forensic science. On Friday, we had the first phase of data analysis using SPSS. Dr. Sunita Yadav will continue with the exercise today. Dr. Suniti Yadav was trained in biological anthropology at University of Delhi. Presently, ma'am works as an assistant professor at the Department of Anthropology in University of Delhi. We have gone through her profile yesterday, and we have also had a session with her. So it is not necessary to introduce her detailedly. We are glad to have ma'am in our midst today as well, and we look forward to an informative and engaging session. I will hand over the session to ma'am. Over to you, ma'am.
Thank you, Dr. Mayank. All right, so we'll start today with again the descriptive statistics, but other parts of the descriptive statistics, as in say distribution of it in what exactly is skewed data or unskewed data. Okay, so when we start with it, so the most important thing is that again you need to understand your data first, and then see what type of tests are required to be implemented or to be used on the data set when you start analyzing your data. So I'll share my screen. All right, so again, if I have to open my data set, the same data set we will use today that we had used earlier. So I go to File, Open, Data. I select Excel because my data sheet was in Excel format. And this is so this is the same data sheet that I had got. I specifically didn't save this data sheet so that you know how do we open it. But once in in such a case where you have changed this, change your labelings and decimal places, then probably you can just go to save and save this file, and then use this data sheet for further use. All right, so I think most of the things are already sorted. Just in case they are not, so we will just do it as and when it comes. So just to tell you everyone once again, so those variables wherein you will have an indiscriminate value or an indeterminate value, such as you have a special sign in that, let us say exclamatory mark or greater than, less than, or equal to in your values, then it would show something of type string here. Okay, and in that case you will have to change, because since there are numbers there, so you have to change it to numeric, and then you have to change it to scale or ordinal, whatever your data set is like. And then nominal is something for which you grade it. So you have to be very specific about your data sheet when you start using it. All right. So supposedly these are the desired changes that you wanted to make to your data sheet. Let us say I wanted to name this as name and this as serial number. Okay. So I can just go to File, then I can go to Save As, and then save it on the desktop on your desired path with whatever name you wanted. Okay. So I can just save it. Okay. So next time when I open it, I can just show it to you. So next time when I open it, I'll just get it. See, so here it is. So next time when I would open it, I can just open this data sheet directly from here, rather than just go to SPSS again, open it and change everything again. All right. All right, so now we go back to, now once you analyze your data, you go to analyze, and when you start with descriptives, so you start with frequencies and let us say age. You have to uncheck this one. All right, go to statistics. This is something of the same thing that we had done in the last class. All right. So this is something that you get here. Okay. Now this is, from this also you can actually understand what your data is like. First of all, for most important thing, without looking at any SPSS or any statistics thing, even if you do normally in Excel, you would get mean and median. Okay, mean, median, standard deviation. So what you have to do is first look at your data. So if your mean and median, if you look at a normal distribution, as we had discussed last time, it's a bell-shaped curve, inverted bell-shaped curve. And if there is in a standard normal distribution, your mean should be equal to median should be equal to mode. So that is the basic thumb rule of statistics, okay, of any normal distribution. So in this case, in any data set that you would use or that you would want to play with, no value would be equal to another value. So that is one thing. So here, if you would see, the mean is equal to 47.98 and median is 45. So if you see, there is a difference. They would not be exactly same because it's something of a population data or any survey data. So they may not be exactly similar, but yes, they would be somewhere close to each other. So in such cases, what you do is you look at your mean, median, and standard deviation. Okay. So if your mean and standard deviation, if your standard deviation is less than twice of your mean, so your data would not have a lot of variations in it. Okay. And if your mean is somewhere near to your median, then also your data will not have a lot of variations. Now, if I look at these variables, age, mean is 47 years, 47.9 years, and median is 45 years. Okay. So there is not much of a difference between these two variables. Similar is with the case with height 157 and 155 and BMI also. So these are the things that make me think whether I should be using mean as representation of my data or median as a representation of my data. Okay. Now that there is not much of a difference between these two variables and the standard deviation is also not very high. Okay. If your standard deviation is something very high, then you need to avoid using mean and median. Then you better use median and your percentile. So that is an important thing that you always need to remember. Okay. Now, I'll just show you another parameter. Now you look at this one. Okay. Now, the mean here is 18 for this particular parameter. The median is 19 and the standard deviation is 8. So standard deviation compared to the mean, when it is 18, it is very high. Where the mean is 18 or the median is 19, the standard deviation is very high. Okay. So I would rather not use mean here. I would rather use median here. So it depends on your observations and data as to what your data suggests. Although it appears that mean and median do not have much of a difference, but see the standard deviation 8.9, which is half the mean. Okay, so never use mean in such representing such data where your data is not normally distributed. So in such cases, your data is skewed. We'll come on to skewness and curtices afterwards. But in such cases where your standard deviation is too high compared to your mean, then you should not be using mean in that case. Okay. And then if you look at the other parameters, the mean and medians are almost pretty similar to each other. And the standard deviation is not also very high. All right. So I hope this much part is clear now. Okay. So now, supposingly, if your data is skewed, if your data is not normally distributed, now your data is left inclined or right inclined. Okay. Now, left inclined would mean that your median that your mean lies left to your median, and right inclined means that your mean lies right to your median. Okay. So depending on that inclination, you would also understand whether your data is normally distributed or not, or it is left skewed or right skewed. Okay. That is an important. Now, if your data is not normally distributed, what you do is we go for log transformations. Okay, we do log transformations in cases where we want to normalize the data. I don't want to separate, don't want to use median or percentiles or anything, but I want to bring my data closer to each other. Okay, if your data is too spread as in, if you would maybe I would show you the Excel sheet, or maybe if we look here, I just want to see the range of the data. Okay. So now if you look at the range of data, so this data is not very expanded, but sometimes it so happens, but look at this age parameter. So the age range is 52. So the difference between the minimal age and the maximal age is 52, which is widely spread. But if you look at the mean and median here, there's not much of a difference, first point. Second point is the standard deviation is not very high. Okay, so standard not very high as in this 12 could be high for something, as in we were considering 8 to be very high. So what makes us determine whether it is high or not? So always have this thumb rule that your standard deviation should be less than half of your mean. Okay, half of your mean means half of 47 should be 23.5, and it is well below that. Okay, some people you keep it at 40%, some people keep it at 10%. It is better to fix your standard deviation at 20%. Okay, so if it is less than half of the mean, then it is pretty okay. If it is not, then you better go to median. Now, if you look at this 18 and this is 8, so it is almost half of the mean. So if you look at your data, your standard deviation is widely spread across half of your data set. Means mean somewhere lies in between, and your deviation is half on both sides. Okay, so you should not be using mean in that case. You should be reporting median in that case. All right. So now if I have to bring my data set closer to each other, so what I do is I log transform my data. That is called as transformation of the data. So in that case, what you do is you transform either natural log or at the base of 10 in SPSS. So what you do is you go to transform and compute variable. Okay. So what you do is you kind of select any variable. Let us say I'm selecting age. Age is my target variable, and I want to transform it as an LG. Okay, then okay, so this is how I do, and I click OK. Now what it would do is it would actually change my existing variable. Okay, so in that case, now look at this thing. Now, my age has been transformed at the log 10. Okay, the base is 10. Now if you look at this, the entire age parameter is now changed to 2. So this, and then my age is changed to natural log. So when I do it at the base of 10, this age is changed to this thing. So if you use a bigger base, your data would be very concise. If you use a lesser base, the data would still be spread out. So I would suggest you to use log transformation 10 for your data set, even if it is too widely spread, because that would kind of bring your data closer to each other, and still it would be an apt variable to be, used for further analysis. So that is one thing. Another thing is that, you kind of if you do log transformation 2, the values would still be higher, but your data would be still spread out. So it is better that you go for log transformation 10 for values that are very high. Values very high, let us say, maybe the income of individuals. But if you're log transforming IQ is a very, very short in range, very lesser in range. So it is not advisable to use log transformations for those variables that have a very low range. If the range is very high, first, if the values are very high, then you should go for log transformation 10. Otherwise, you can go for natural log or log 10. That is up to you. What kind of log transformation do you want to use? Now, that is one thing. The other thing is, when you do log transformations, sometimes there would be some variables that would not be able to be analyzed, because then there would not be any exact interpretation that you would be able to make. So first, create another variable for it and then start doing it, rather than changing the entire variable. Right now I've changed the entire variable here, so I may not be able to analyze or interpret the outcomes that such as in regression or variance afterwards. Okay, so it's better that you create another variable and then do it. That is one thing. Then I would just show you then how do you kind of go for testing of variance. Now we have variables that are normally distributed. We have variables that are not normally distributed. So we look at mean, median, and standard deviation, the basic thumb rule to understand your data. Skewness and curves we'll do afterwards, but first focus on this. Now, if I look at this, I would rather see which parameters are normally distributed, which are not normally distributed. So what kind of tests do I apply on them? So the first thing that you would want to look when as a researcher is to see if there are differences between any 2 or 3 groups in my survey. Okay, let us say I've got a response on maybe the income. Okay, income, and in my responders there are both males and females. So my research question is to simply look whether the mean or the median, the median income is different between these 2 groups or not. Okay, that is my first question that I would want to see. So in biological research, you have cases and controls. You kind of divide your data in case and control group. In a survey, you may have different groups based on your question. Maybe you can have a group who is a student group, or an older retired group, and a teaching group, or a working group. Okay? So these are 3 groups depending on my research question. So now I want to see what is the difference in the mean age or mean mean BMI between males and females. So if I want to do that, what I do is first of all see what is the mean BMI amongst males and mean BMI amongst the females. Okay, so that is one thing that I want to do. Now, for that, what SPSS would do is it would not separate males and females when I go for, because if you go back to the last lecture, if we go through frequencies, I just want to calculate the BMI and it would show me for the entire group, not separately for males and females, right? But I want to see it separately for males and females. So what do I do? See, this is how we got it in the last lecture as well. So what I go is, I go to data and I go to split file. Now, split file is something of a very important parameter or a very important function that you may have to use a lot many times. Okay. Now, in split file internally gets split. Okay. So SPSS will split the file based on what you give. So I want to compare groups based on males and females. I send it on the right side and I click OK. You can layer your files in multiple ways also. Okay, multiple ways as in I want to separate or split my file within females. I want to see females who are smokers, so I can layer my file. Okay, so I go to data, I go to split file, I click on whatever parameter was there. Let us say I wanted to separate males and females. I can do it either way, either through this or this. So I coded them. I'm using the codes here and compare those. Okay, based on this. Clear? And click OK. Now my file is layered by that. So when it is, whatever number of variables would be there in my data sheet, it would split my file based on that. Now, if you look at this, now sometimes when you would open your file, you may see a lot of dots here. You know, it so happens when you kind of reopen a file again and again, SPSS kind of gives you this blank sheet and gives you these dots. Doesn't mean that your data sheet is missing here. If you would go somewhere in your data sheet, maybe in the middle or in the end, you would be able to see your data sheet. So either you can kind of delete these, or you just let it be like that and keep analyzing your data. So these are blank sheets for SPSS. Okay. Now I can do it either ways. I can split my file with M and F because there are only 2 codes. Even if there are 3 codes, okay. If you look at this, maybe the BMI code here, so you can see here 0, 1, 2, 3 here. So I can split my files to any number of layers. Okay, that is an important thing when you start comparing your data and start comparing your groups. So what I do is I layered my file by 6 and then go to analyze descriptive stats. Same thing again and repeated. See, now clearly my BMI is split into 2 groups. 0 I coded for males and 1 for females. So amongst the males, the BMI is, so I just look at my data. So 0 is males and 1 is female. So this is my data. So this 0 is for males and this 1 is for females. And now my data is separated into 2 separate outcomes. Mean BMI, median and standard deviation for BMI for male and for females. Now I want to see whether this BMI in both the groups is statistically significant or first different or not. So it appears that this mean is 22.8 and this mean is 22.1. So ideally it feels that they are very similar. So the mean of males and mean BMI of females is not very different or different from each other. But how are we going to be sure about it is by applying the statistical test. Okay. Now, considering the standard deviation, it's very low, it's very low. So when you compare means, you apply when it is between 2 groups. Remember, when it is between 2 groups, you use t-test, students t-test. Okay. And when it is between more than 2 groups, you apply ANOVA. So when you are comparing means, you use students t-test between when it is 2 groups. You use ANOVA when it is more than 2 groups. Okay. So I go to analyze, compare means, and I go to independent t-test. Okay. Now I want to compare. Now, when I compare this, I also have to remove split file for the reason that when you compare this, you see this. So I want to compare the BMI, which is a scalar quantity, and the grouping variable has to be sent here. On what basis do I want to compare the means between the 2 groups? So that is your grouping variable. Now, the moment you send grouping variable here, it would ask you to define the groups. So group 1 is 0, that because I coded them likewise, and group 2 is 1. Okay, so this is what you do. You define the group, you send your variables here, And you can test as many variables as you want to between males and females right now. Let us say I want to do BP also. Then I want to compare WHR, cholesterol, HDL, whatever number of tests I want to compare, variables I want to compare, I can just do it in a single click. Now see, this is the table. So now don't get confused with so many variables. I'll just show you one variable, one or two variables. All right. So maybe I just take another variable as well. And show. All right. So now, when you look at this, you find that you get equal variances assumed, equal variances not assumed. First of all, when you have your null hypothesis and alternate hypothesis, you first assume that your data has equal variances from either side. Okay, and both the groups do not have unequal variances. So you kind of assume that your null hypothesis is that the groups have equal variances. Okay, then only you start using this test. So what I look at is you kind of look at this equal variances assumed, and then you look at the F value. And if you look at the T value, more specific is about the T value and the significance. Okay, so simple that you have to look at is you look at the significance and the T value. Okay, higher the T value, lower will be the significance value, P value. The significance is P value. You have to look at the two-tailed significance because you are looking at the 95% error, 95% confidence interval from either side, from the left side as well as the right side. That is why you have to look for P value significance two-tailed. Okay. So you look at P value. There's an inverse relationship between T value and P value, significance P value. The moment the T value increases, P reduces. Okay. So if your T is low, your P would be higher. And if your T is high, your P would be low. Now, if you look about how do you interpret this? So BMI, I see T is 0.546 and this significance is 0.588, which means when your null hypothesis is rejected, your null hypothesis is accepted and your alternate hypothesis is rejected, that there is no difference between the two groups. Okay, so in this case you assume that there is no difference between the mean BMI between males and females. Okay, so that is accepted. And in simpler words, just to interpret your data, that was something very statistical way I used. So simple, if I would have to interpret quickly, I would say there is no mean difference in the mean BMI of males and females just by looking at your significance value, two-tailed, because it is 0.58. If it is less than 0.05, if it is less than 0.05, which means the difference between the two groups is there, which means mean BMI of males and mean BMI of females, there is a difference. So either of them could be high or either of them could be low. Now, if I look at this, okay, look at WHR, waist hip ratio. Now I see at T. Now the T is high and the P is low. Okay, P is 0.002, which means there is a significant difference in the WHR between males and females. Clear cut. So if we see the mean BMI, mean WHR. Okay. So now look at this. The mean WHR of males is 0.98 and females is 0.88. Look at this value. 0.98 and 0.88. Okay, so but to say statistically, we have to look at the P value. Okay, so the P value is 0.002, which means there's a significant difference in the WHR, mean WHR between males and females. Now, on factor analysis is not something, you see an outcome. Factor analysis is something, how many factors are very strongly explaining your entire data set or most important contributors to your entire data set. Okay, that is something called as factor analysis. So on factor 3, factor 3, only one component is there and the value is 0.97. Okay, so if you see this is something I would not be really bothered about it, because the value is not very small for it, because it is inverted. Okay, had it been the component matrix and the values would have been higher, I wouldn't be interested in that compared to the rotated component matrix. If the values would have been low, I would have been pretty interested in that. Okay, so this is more so similar to stamping to correlation and regression analysis compared to your simple factor analysis. So you should always between factor analysis after your correlation analysis, so that you kind of know what are your important data sets. So if in any data set, if any number of responses in a survey that you get, okay, and your outcome is vaccination, yes or no, okay, and there are thousands of questions that you've already prepared that affect vaccination status, yes or no, but you only would want to choose only those 10 to 12 parameters that are important for vaccination status. Then in that case, you definitely need to go for factor analysis. It's a very boring test, but it is a very strong test that has to be used. So always remember, correlations are between 2 variables or 3 variables, 4 variables, but relationship between 2 variables. If it is between 2 variables, you go for simple correlation, but if you have to control for an effect, you go for partial correlation. Then you go for regression test. Regression first is your linear regression. Linear is for when your dependent outcome is linear and you want to understand how one unit change in your independent variable is leading to a change in or affecting your outcome. That is when you look at the regression analysis, linear. When you look at binary, in binary your outcome should be dichotomous. Okay, if your outcome is binary, means 0 or 1, 1 or 2 or 3 or 4, means you have only 2 categories. It is dichotomous. Then you go for binary regression, wherein you see first the odds ratio and in comparison to the normal group. Second thing that you can do is you can form a particular group forward or backward, where you find the most contributing factors to your outcome. Heart attack, yes or no is my outcome. But if I want to see whether smoking, age, total cholesterol, BMI, WC, these parameters, how they're affecting my heart attack outcome, so I can use binary regression. If I want to see of all these parameters, age, sex, smoking status, total cholesterol, and BMI and WHR, which are the most common and most important contributors to my heart attack, I would select forward or backward, depending on the ease of use. I prefer backward for the reason I get to know which parameter is slowly losing its importance in the analysis. That is when you do regression. Now, the factor analysis is also using the principal component analysis. But once you have a feel of this, then principal component analysis is very, very simple. So, factor analysis is to understand of the overall hundreds of parameters that you have collected in your data set, which parameters are most strongest in your data set. That is your factor analysis. Okay, and principal component analysis, it kind of uses those algorithms to reduce your data into correlated factors. So only those factors will have those who have correlations between themselves, amongst themselves. So principal component analysis would use those factors to produce a matrix and eigenvalues. Okay, again, for interpretation of eigenvalues that you got in this table earlier. So an eigenvalue of 1 or more is accepted for that a factor is important. Now, if you look at this, okay, Okay, look at these eigenvalues. So value of one or more. So these three components, these three factors, 3 points are important as factors in my data set. And these two, and there are two data sets, two parameters in my data set that are very redundant or not very important in my data set. Okay, so this is something that you should be knowing when you start as a beginner, and then you can move on to further interpretations of the eigenvalues and principal component analysis. I hope this much clear. Dr. Suchita, can we wind up here? Should we continue it further?
Dr. Suniti, have we cleared all the topics? I think it has been cleared,
Two
right?
are left actually, as in cluster analysis and discriminant function analysis. We can move into that, but I'm not very sure how much would the participants be able to take in, because these are very specialized tests. Until factor analysis, the story is all related to each other as to step by step what all the participants have to do when they start doing the research paper. So, but if you suggest, we can we can do either ways. If we want to kind of move to cluster analysis, we can do that. Else we can kind of give them an interpretation as to what is to be done.
Dr. Suniti, then in that case, since it's going to fall under the advanced statistic part, we'll keep it for some other session. This one
is better. Because once our participants have a feel of as to they start playing with small numbers, then they would be able to understand as to what is to be done. Otherwise, it would be difficult for them to absorb cluster analysis and discriminant function analysis. Although it is just 2 clicks away, but interpretation of that would be again into different sets.
Sure, we can have another session on advanced SPSS statistics someday. So I hope all the participants will be clear with this much, since it's the basic inferential and descriptive statistics that is being taught to them.
So to summarize the entire, entire 2-day lecture, I would always suggest you, first of all, your Excel sheets should be clear. Second is, when you open your Excel sheets in your SPSS, you should be very clear with your data view. Data view, as in, if you look at this variable view has to be very sorted. What is going to be my numeric? What is going to be my string? If supposedly there is a small dot, now let us say look at this waist circumference value. It is coming out to be string. But waist circumference is something which is scalar, continuous variable. So I have to change it to numeric so that SPSS starts reading it, and I have to change it at both the sides. Always remember, these two things should match. This type and this measure should match with each other. Otherwise, your interpretation would not be clear. Increase or decrease your decimal values. Label or relabel your entries here. These are your variables, and if I want to relabel them, BMI status or BMI coded, I can put it here. That is up to me, and that is how you do it. Be very clear about it. And alignment, if you want to change it to right, left, or middle, you can change it from here, whatever way you want to see, look at your data view. Then you don't have to do much with your data view. You just have to analyze your data. If it is continuous variables, let us say, the height of individuals, so the score of first class, second class, third class, and fourth class, then it is continuous variable. To explain your continuous variables, always go for your descriptive statistics. That's the first thing. Within descriptive statistics, you start with mean, median, standard deviation, range, and your interquartile range, 25 to 75th percentile. If you have to compare the groups, then the next step, whether I want to compare between 2-3 groups, primary or secondary or senior secondary, that way I have to go to split file, split my file, see the mean scores or the median scores, whether they are different or not. Okay, split files. After splitting file, I'll get different scores for primary, secondary, and senior secondary. But now, if I want to compare the results of these 3 groups, these are 3 groups. I would go to, if I'm comparing mean, I use ANOVA. If I'm comparing median, I use Crystal Wallace. If I'm comparing 2 groups, I go to t-test. And If I'm comparing two median groups, and I use manually. First part of the descriptive statistics. Then second part is a correlation where you see the relationships between two variables. Means the BMI and the nutrition status, BMI status, and the scores of students in different groups, or maybe the income of an individual and the quality of life, or maybe stress of an individual and quality of life. These parameters, if you want to just see the correlation, how one factor is related to each other, how one factor is related to each other. That's all. Simple relationship. But if I want to see how one factor is affecting the other parameter, I would have to go to regression analysis. And based on my outcome, whether it is linear, whether it is dichotomous, I would choose linear, binary, or multinomial. In linear, we have continuous variable. In binomial regression, I will have my dichotomous outcome. Means my outcome is yes or no. Vaccinated, yes or no. iPhone possession, yes or no. Okay. Computer or laptop. Okay. Like this. But in multinomial, if I have three responses, 1, 2, and 3. Okay. Say for example, normal phone, Android, and iPhone. Okay. Normal phone, and within the smartphones are 2 categories. So I've got 3 categories now. I can switch on to the multinomial regression. But I would always suggest you to make 2 data sheets for comparing your three outcome variables. If you go to multinomial, you can always put your dependent variable, let us say 3 category variable here. And what reference category I want? I want first reference category. Then I can put on continue and put all the factors that affect this variable here. Now, in multinomial, what I have is factors and covariates. Factors are something that I want to look their effect on the BMI. And covariates are something called as confounders. I put them here. Okay, then again, which model do I follow? This is fine. Full fair. You don't have to clearly, kind of select on this. I would rather, as a beginner, I would suggest not to do anything here. Then you click on this is fine. This is also goodness of it can be clicked. Options is already done. P value is 0.05. And then click on OK. And I get this whole lot of interpretation. As in for reference category 1, I get all the parameters. Since my WHR was not coded, it is given for all the values. So look at this. Very clear. So age, again, I look at exponential beta and the p-value. So I'm so unhappy to see that my BMI is not affected by any of these parameters for the reason none of these parameters have a significant p-value and exponential beta is also changing. Now, one very important thing is when you look at the regression output, sometimes you would get these error values. Okay. Now you would be confused as to what is to be done. So most of the manuscripts or most of the journals, they kind of report this value directly first. Or what you can do is you can just copy this table and put it in an Excel. Okay, and in that case, you can just change this entire table to number. So the moment this is done, your error values are changed to a specific number. So you can report that number in that case. Okay, so that is something that you can do. Otherwise, these error values can also be reported because they're standard values. These error values also reflect that your data set is very low to be explained by this particular p-value. Okay, your exponential beta value is very low, so that the p-value is 0.9 and almost equal to 1. Okay, so that is when you do this. So this is absolutely okay to report error value. Else, what you do is you go to an Excel sheet, paste it there and convert it to numbers, and then you can use. So that is it. Thank you, Dr. Ashika. Thank you, Dr. Mayank, and thank you, Dr. Suchita. And thanks to all the participants.